So welcome all. Today we are learning something about routing protocols. In this video actually we will see some basics of routing, and then later on we will try to see specific algorithms. So as you can understand, in an internet we have actually the combination of networks. These networks are actually connected with the help of routers. So whenever a datagram goes from a source to destination, it will probably pass through many routers, right? If you remember, while sending a packet we have a field number of hops, right? So it goes through many routers. So what happens is we will have to uh, consider this thing, how the packets would be routed, how this packets will be routed so that it would reach the destination in optimal time, right? Optimal means something, right? See, when a router actually receives a packet, so what will happen? Uh, it will have to decide to which next router these packets will be sent, you know? So this decision will be based on optimism. It will try to find out which is the optimal path, right? So what can be optimum, right? You will see here, you will see cost metric. Cost metric means the cost of passing through the network. Okay, so that will be, we will consider this thing as metric. Let us assume passing through a particular network we have a particular cost. Okay, so we will consider this cost as metric. So what the thing is, in internet, as we see, we have IP datagram, so IP packet where we have a field number of hops. So it keeps track of how many hops it should go, how many routers it can pass, you know? So accordingly we understand that a path in which it will have to move more number of routers, that will be a bad path. However, a good path will be where we will have to go through less number of routers. So in that case we will have to minimize the number of routers we pass through, right? Okay, so that is optimism. We are trying to optimize the number of routers we are passing, right? So we are trying to somehow reach the destination with less number of routers passed. So for this what we can do is, at each router we can maintain a particular table kind of thing, where we can store the information in which direction the packet should go. When a packet is received, it has a destination address. So after reading this destination address, the router has to decide in which direction it has to be sent. So this table should maintain the information that particular IP address request is coming. It should go through this particular router. So now this thing can be, this table can be static or dynamic. Static means a table will be manually entries will be done, right? And in a dynamic table what will happen, it will adapt automatically whenever there are some changes in network. Maybe some link was down, so whenever something happens they need to update for a better path, right? That is the thing. So if it is done automatically, it is dynamic. If it is done manually, it will be called as static tables. So now if at all it is static, it is being done manually, that is different thing. But if at all something is being automated, then we will need some programs, some particular rule based things, right? I should say we will need some algorithms. Actually, routing protocols are such thing, built for dynamic routing. I should say for creating this routing tables dynamically. So this routing protocol will have certain rules and procedures that will enable you to make this, I should say, update this table automatically on this particular internet. Whenever something happens, some link is down or something, then something can be updated on a particular router. These routers can transmit this information to other routers so that they could update their own routing tables. So such kind of things are there with the routing protocol. We will see some routing protocols later. Now the other thing you have to understand is interdomain and intradomain routing. So now you can understand that in internet can be so large that one routing protocol cannot handle the task of updating the routing tables of all the routers. So what we are doing is we will divide it into some autonomous systems. These autonomous systems are actually a group of networks. Means this network, several networks will be there, they are connected with each other, routers are there, and all these are being maintained by a single administration. So that will be called as autonomous system. So now there are two kind of routings will be needed. A routing for the routers inside this autonomous system. Let me show you the image. This is an autonomous system. So you have a router, several routers inside this, and if you have to route the packets inside this autonomous system, you will have certain protocol. And if you will have more than one autonomous system and you need to transmit data between these autonomous systems, then you will need some protocols. You will call them interdomain protocol. Okay. So here these are the something shown. Okay, autonomous systems, and these are the routers which will, this bold line will be using interdomain routing, and these simple other lines they are using all intradomain routing protocols. So routing protocols can be divided into two types. They can be intradomain and interdomain, right? So some intra-domain routing protocols are basically RIP and OSPF. See, RIP is based on distance vector routing algorithm, you will see, and OSPF is based on link state routing protocol. Another protocol is BGP, which is inter-domain protocol. It is based on path vector routing protocol. So in the coming videos we will see all this routing protocols. Okay, so for now we will see the next things in next video. Thank you.